In this video, we're going to look at implicit differentiation. So this is another tool we can use in our bank of knowledge of taking derivatives. For implicit differentiation, we're going to use this whenever we have more than one term with y in it, or another variable. So if you even consider 2xy plus y squared equals x plus y, that's actually pretty difficult to differentiate with respect to y here when we're using the methods that we know so far. However, let's try with an easier equation and try to take the derivative of y prime to get y prime. Well, we can probably use the chain rule here to do this. And let's see how this can be done. So by the chain rule, we're going to differentiate every single term. So the derivative of x is just 1. Here we have to take the chain rule method because we have a function of a function. So the outer function is to the power of 3. We're going to use our power rule first, bring down the 3, leave the inside alone, and then subtract 1 from the exponent. Now by the chain rule, we'll have to multiply by whatever the derivative is of the inside, which we're just going to call y prime of x. And then the derivative 2 is just 0. Now to solve for y prime of x, we're just going to do some rearranging. I'm going to subtract 1 on both sides, and then divide both sides by 3, y of x squared. And then that is our answer. That is y prime of x. So now let's try another example. We'll do the one that we're looking at before. 2xy plus y squared equals x plus y. We're going to use a similar method to the one we did here. We're going to apply the chain rule. So when we're applying the chain rule, and every time we differentiate with respect to y, that means by the chain rule we have to multiply by y prime, and then we're going to rearrange the equation to solve for y. So let's try this out. Our first term here, we need to do the product rule because we're multiplying two functions together, 2x and y. Okay, so then when we differentiate 2xy, we're going to differentiate 2x first, which is just 2, then leave y alone. Plus, leave 2x alone, and then we'll take the derivative of y, which is just y prime. For y squared, we'll just differentiate y squared, which is 2y. By the chain rule, we need to take the derivative of y, which is just y prime. The derivative of x is 1. The derivative of y is y prime. So we are differentiating with respect to x. That's why this, when we differentiate y, it doesn't become 1. It just becomes y prime because we're differentiating with respect to x. So that's your first step. Now you're going to collect y prime on one side. So this looks like 2xy prime plus 2y times y prime minus y prime is equal to minus 2y plus 1. So I just threw all my y primes on the left-hand side for now. Then we want to factor out our y prime. So y prime is going to be multiplied by 2x plus 2y minus 1, which is equal to 1 minus 2y. I just swapped it over. And then now we want to isolate y prime. So y prime is 1 minus 2y all over 2x plus 2y minus 1, and then we're done. So we found y prime, and our answer is in terms of x and y, and that's okay. Let's try another one. So our first step is to differentiate every single term in here. So 2y is the derivative of y squared. Then by the chain rule, we're going to multiply it by y prime. Then we'll take the derivative of x squared, which is 2x. Remember, we're already differentiating with respect to x, so that is our final answer for that term. And then we're going to have to use the chain rule here for sine xy. So we'll take the derivative of the outside, which is cos xy, and then we'll take the derivative of the inside. And we have to use our product rule here. So the derivative of x is just nothing, is 1. And then we'll leave y alone. Then we'll leave x alone and take the derivative of y, which is y prime. Now I'm going to simplify this a bit more. This y is going to multiply with our cos, and this xy prime is going to multiply with our cos xy. Now I'm going to do some rearranging, move all my y primes to one side. Then I want to factor out the y prime. So I'm left with 2y minus x cos of xy. And then we'll divide both sides by that to isolate y prime. And then that's it. If you follow these steps from example 1a, you should be fine. Okay, let's try it again. Find dy dx. That's the same thing as saying find y prime. And it's a bit more complex now. It's going to take a bit longer to solve for this, just because it's more involved. Now let's do one term at a time and focus on one thing at a time. So we're going to look at the derivative of y to the power of 5. You're going to bring the 5 down, take 1 from the exponent. And because we're differentiating with respect to x, we're going to multiply this by y prime by the chain rule. Here we have to use our product rule. So the derivative of x squared is 2x. Then you leave y cubed alone, plus leave y squared alone, then take the derivative of y cubed, which is 3y squared multiplied by y prime. The derivative of 1 is 0. And then we need to use the product rule here. So we'll take the derivative of y, which is y prime, leave x to the power of e to the power of x squared alone. Then leave y alone, then take the derivative of e to the x squared, which is e to the x squared times 2x by the chain rule. Now we want to throw all of our y primes to one side again. Then we want to factor out y prime. Then divide both sides by 5y to the power of 4 plus 3x squared y squared minus e to the x squared to isolate our y prime. So then y prime is what we have on our right hand side here. And then that's it. We're going to try the next example, and it's another tangent line type of question. The only difference here from the other tangent line questions is we're going to have to use implicit differentiation to find y prime, which is our slope equation, and then we'll plug in the point 1, 2 after to find the actual numerical number for the slope. So let's go ahead and do implicit differentiation on this equation. So the derivative of x squared is 2x. So to find the derivative of 2xy, we're going to use the product rule here. We'll take the derivative of 2x first, which is 2. Leave y alone. Then leave 2x alone, take the derivative of y, which is y prime. And this next term, we'll again use our product rule. So we'll take the derivative of y squared, which is 2y, multiplied by y prime according to the chain rule. Leave x alone, plus, leave y squared alone, derivative of x is 1. And then this is equal to 0, because the derivative of 2 is 0. Now we're going to rearrange this equation. So one side is only going to have y prime terms. And then we'll factor out our y prime. Then divide both sides by 2x minus 2yx. So we are given a point 1, 2. To find the numerical value for our slope, we're going to plug in 1, 2 in for x, y. So y is 2. This becomes 2 squared minus 2 times 1 minus 2 times 2 all over 2 times 1 minus 2 times 2 times 1. So that's 4 minus 2 minus 4 over 2 minus 4, which is negative 2 over negative 2, and that's 1. So our slope is 1. Our final answer, we're going to plug our slope into our regular equation with that point. So that's y minus 2 is equal to 1 times x minus 1. Or in other words, it's really easy to rearrange this. This is y is equal to x plus 1. And that's it. So go ahead and try the try it yourself questions. There are 4 of them, and they follow the same kind of format as the examples we've done together. So go ahead and do that and press play for the solution. Okay, so for the first question, you're going to differentiate each term. So the derivative of x cubed is 3x squared. For y cubed, you need to use the chain rule. So your outer function is the cube. So we're going to put the 3 down, subtract 1 from the exponent by our power rule, then multiply by y prime. The derivative of 1 is 0. Then we're going to move this 3x squared to the other side, and then divide both sides by 3y squared. In B, we're just going to find the second derivative of our first question here. So we're going to take what we have here and just apply the quotient rule. And then that's it. In C, you're going to take the derivative of one side, which is y prime, and then we're going to have to use product rule here. So you'll take the derivative of x, which is just 1, leave sign y alone, plus leave x alone, take the derivative of sine y, which is cos y, and then because we're using the chain rule here, because we're differentiating with respect to x, we have to multiply by y prime. Then we need to rearrange so that one side has y prime. So we can factor out that y prime. And then we'll isolate the y prime by dividing both sides by 1 minus x cos y. And that's it. Then for your final question, we're going to differentiate every single term here. And of course, you use implicit differentiation because you have two terms with y in it. And we have to use a chain rule as well. So for our first one, whenever you take the derivative of the function e, it remains the same. So that's why I have e to the xy. And then we have to use our product rule to differentiate xy. Derivative of x is 1, leave y alone, plus leave x alone, take the derivative of y, which is y prime. Then for cos y, we take the derivative of the outside function, which is negative sine, leave the inside alone, then multiply it by y prime. The derivative of 1 is 0. Now we just have to expand. So e, the xy is going to multiply with y and xy prime. Then we're going to rearrange so that y prime is all on one side. So these are the two terms with y prime. Then we're going to factor out the y prime and then divide both sides to isolate y prime. So we divide it by x e to the xy minus sine y. So that is the equation to find the slope. Now we want to find the actual numerical slope by plugging in x equals 0 and y equals pi over 2. So that's what we did here. And then we just evaluated it. And you get a slope of pi over 2. Then finally, you're going to plug your slope and your point into the standard way of writing an equation. So y minus pi over 2 is equal to our slope multiplied by x minus 0, or in this case just pi over 2x once you simplify. And that's it.